Hello friends, welcome to this special video on Hyperledger Fabric Blockchain. We were getting so much of inquiries, proposals, and requests related to Fabric Blockchain application development. Considering so many factors from those interactions, we came up with a tool that will generate the source code to kickstart your Hyperledger Fabric Blockchain project. Sounds great, right? As an introduction, I want to add one more thing that this tool is not a freely available one, but this has been developed as a commercial product. So please watch this video completely and understand what we are offering before taking your decision. To download the source code, go to the website evolvingit.online. To get a fair understanding about what you're going to download from the site, I recommend you to visit the product details page and see what all features are included in this project. If you have any queries, feel free to reach out to us. If you want to continue with downloading the project, click on Create Your Own Fabric Blockchain button. You will be directed to the payment screen. After making the payment, you will reach the Blockchain Configurations page. Here you will enter the configuration details about the blockchain you want to create. Enter your project name, network name, channel name, and the chain code name. I'm selecting 3 organizations and naming it as org11, org22, and org33. Let the number of orders and peers be the default values 1 and 2 respectively. Click on the Submit button. It will start processing your request. Wait for some time to finish it. A zip file with the project name will be downloaded to your Downloads folder. I will first show you the steps to run the applications and the functionalities included in the package. Then we'll have a high-level view of the files and the settings. That should give you a fair idea about the project you own and the options to customize as per your requirements. When you unzip the file, there will be 4 directories and a general config JSON file placed inside the project folder. Open a terminal pointing to Network folder. Go to Local folder. If you list the items, you can see there are some directories and script files been created here. Start the blockchain application configuration and execution using the init.sh file. We'll go in detail about this file content and use later. You need to use init.sh file only for the first time project setup. For the subsequent project execution, you can use start.sh file. There's a cleanup process happening now. It's checking if there are dockers related to this project is already started running. Then this will terminate those processes. It started downloading the binaries. The Fabric version I have specified as default is 2.2.3. But you can easily change the version using the start.sh file. You can download the binaries or Fabric libraries only once unless you're going to change the version later. I will show you the settings for not to download the files every time you run the application. Started creating the network. Now it's creating all the required crypto materials for admin and peers. Executing Docker Compose file for CouchDB and network. We already have Dockers up and running for Fabric CA, which is required to create the crypto materials. Now all the Docker containers are up and running. You can see the local host port numbers used by each Docker container. Channel has been created. Setting up the anchor peer for each organization on the channel. Chain code has been packaged for deployment. Now installing chain code on each peers connected to the network. Performing the chain code definition approval processes. The chain code definition is validating only for anchor peers of each organization. After the approval from all the organizations, chain code is committed on the channel. And thus our Fabric blockchain is up and running. Now, let's move on with setting up other components. Open another terminal for a client application and run npm install to install all the dependent libraries specified in the package.json file. It will take some time, so I'm fast forwarding that part. All the libraries have been downloaded for the client application. Now, open a third terminal for the server application and follow the same step. npm install. Run the command notapp.js or notapp to start the server application. The server is listening on the port 3001. Now let's start our client application. This application has been built in React.js framework. To start the application from development environment, run npm start command. This is the UI for our Fabric blockchain application. Here's the menu home, add employee, show employee list, and for logout. This UI has been built just to demonstrate the Fabric blockchain functionalities. You can use this pattern as it is or modify it, or else you can use a completely different framework to develop your own client application. The API call will be similar and can be easily modified to incorporate the services to any client application framework of your choice. First of all, we need to register the application users. Click on the Register Now link, and I am registering one user for each organization. Registering the email ID user1@gmail.com for org11. In the real-life scenario, there will be different client applications specific to their organization will be developed, and the server API will be common that will expose the blockchain functionalities. As we are using the local host to set up all the organizations, we are providing an option to select the current organization when using this application. I am registering user2@gmail.com and user3@gmail.com for organizations 2 and 3. After the user registration, I'm going to add employee details to the blockchain. Don't get confused with application users and employees. Users are the actual blockchain users in the organization, and we are managing the public and private employee records in the blockchain. I'm going to add some employee details to the application. There's no employee records available in the system. Enter the employee details. And click on Save. Oops, I didn't log into the application, so it is showing authentication failure message. Log in as user1@gmail.com. Here we're just showing the message not redirecting to any page after the successful user login. Now add a couple of employees to the application. Two employee records have been added to the blockchain successfully. Click on Show Employees List will display the records we just added. Selecting a record will enable the options to add personal info, view personal details, and delete the selected record. As I haven't added any personal details about the employee, we're getting this message. I'm going to add personal details to this employee. I have some sample files in all general formats like JPG, TXT, PDF, doc, PNG, etc. to demonstrate how it works in IPFS file storage environment. I'm selecting two test documents in different formats and click on Save button. Here we're getting an error message saying that IPFS upload failure. This is because I didn't start the IPFS service. This will be running on the server system, not on the client side. As we are running everything in the same local host, let me open another terminal to start IPFS service. Enter the command IPFS daemon. IPFS service is listening at the port number 5001. One more thing I need to verify is the node version. Here it is showing the version 14.19.1. If you use the node version less than 16, IPFS upload functionality is not working properly. I'm upgrading node version to 16.14.0 using the node version manager. This node version is already installed in the system, and now it's using that version. Let me run the server application. Now we are all set to continue the exploration. Click on Save. We need not restart the client application or the blockchain service because these are completely independent components. Private data has been saved to the blockchain successfully. This confidential data should be accessible only to the org11 users. You can check the private data and files uploaded. These encrypted files are uploaded to the public IPFS storage environment. Let me add private data to the second employee also. Here also I'm going to be adding two files. And save. You can see the contents of PNG and PDF file formats. Let me log out and log in as the user from org22. Successfully logged in. The user from organization 2 can see the public details of the employees, but when clicked on the button to view the private details, it is showing the error message because we have configured the blockchain in such a way that the private data is accessible only to the organization which added the records. Adding another employee record by the user from org22. The new employee record has been added to the list. Now I'm adding personal info about this newly added employee. I'm uploading more documents this time. You can remove a document from the selected list using the delete option. Add more documents. Now click on Save. Private data has been added to the blockchain. You can go to the View page and see the record and uploaded files. Finally, let me log in as a user from org33. Successfully logged in. Go to the employees list. Employee public information is available for the org33 also. But when trying to access the private data, you'll get an error message. That is how private data is managed in the permission blockchain environments. Now let me show you the CouchDB, which holds the current values of the ledger status. To know the port numbers where different Docker containers are running, you can list the Dockers for details. These 6 Docker containers are for chain code installed on each peer. These are the peers from different organizations. Here the CouchDB containers and their details. CouchDB for peer 0, org11 is running at the port number 2022. Port numbers from 2022 to 2027 are used by CouchDB containers corresponding to each peer. Let me log into the org11 DB. Here you can see the public data and hash collections of private data and private record for org11. These 2 entries are hash collections corresponding to the private data added from org11 and org22. The last one is a private data collection added from org11. Let me open this record in JSON format. Here, in the image URL, you can see the uploaded file names and CID indicating the IPFS file stored in the ledger. Another thing I want to show you here is the user details stored in the ledger. When you open the test channel _my chaincode entry in the database, you can see all the registered users. Open in JSON format. Here, user ID and password hash along with other informations are stored in the blockchain. Let me open DB corresponding to org22 peer. Port numbers 2022 and 23 are for org11 and 2024 and 25 are for peers in org22. This is the hash record for the private data added from the org11. See, the details are not human readable as it is. And this record is the private data added from the org22. Let me try to open the file using CID from IPFS. If the file is not encrypted, you can directly open it using IPFS URL and CID. Let me search for the file in IPFS using content identifier. 404 error. There's something wrong in the URL. Let me check how did I search before. Oh, okay. There's a /IPFS needed in the URL. I'm copying this URL and then take a content identifier from here. The file has been downloaded. If you open and see the content, it is all encrypted. And finally, let me open a CouchDB created for org33. Here, you can see public records and only hash values for private data added from org11 and org22. Closing all windows and bringing the network down. Next, I will have a high-level walkthrough of project files. Let me open the projects in VS Code. The chaincode source code has been placed outside separately in a folder. One important thing I want to mention here is regarding the collection config file. This file is used for the private data management. In this organization level private collection, we have included all the organizations in signature policy for endorsement. For an organization's private collection, peers from other organizations need not endorse the transaction. We have done this because when running all the peers in the same system, frequently we are getting endorsement policy failure error. So for org11 private collection, only org11 MSP.member needs to endorse the transaction. Similar the case for other orgs private collections endorsement settings also. This chaincode development has been done in Golang. You can easily replace or modify the chaincode functionalities as per your requirements. Next, Client UI. Client application has been built on React.js framework. There's a logical layering in functionally implementations, and components or functionalities are segregated in different files for easy understanding and modifications. Hyperledger Fabric Network. All the script files have been dynamically generated based on your configuration entries. Template and scripts for creating common connection profile file. Here is the server API node JS application. For the file inscription logic, we have used AES256GCM cipher. But if you want, it can be changed very easily. Add a strong password and salt to make the file buffer inscription more secure. IPFS functionalities upload and get from IPFS. In the beginning, I have mentioned about the init.sh file. Let me open it. Here it is giving write access to the folder and calling start.sh file. In the start.sh file, you can change the Fabric version and CA version. From this file, Fabric blockchain setup scripts are calling sequentially. Here, the Docker Compose files, CSS file for setting the styles to UI. You need not download the Fabric binaries when you run the project every time. To prevent deleting the bin folder when you take down the network, you have to comment these two lines in the network.sh file. Save the file, open bootstrap.sh file, and set these two variable values as false, and save. I hope now you got a fair idea about what is included in the package. Thank you for watching this video. Please let us know if you have any questions or comments.